Welcome everybody and good afternoon and thank you so much for joining us today for this event. Possibly good evening for some people as well. I see we've got some people from across different time zones, and it's great that you're joining us today for this session. Um, as Claire said, my name is Glenn Patterson. I am a science teacher and have been for the past 16, 17 years. I am one of the credible specialists at Pearson on the biology team, and I work across both GCSE and A-level biology, providing support events and writing resources. So I'm thrilled to be here today to to go through this presentation with you and share some insight into the biology A-level A and B, both specifications. We're going to look across both of them today. And the main focus of today's session is looking at the maths and statistics that's required for the A-level biology course across both specifications. Just as Claire said there, the resources are available to you. There is a PDF of the presentation I'm going through today, and obviously you'll have access to that, and you can keep that for after the presentation in case you want to make any notes or things like that. Today what we're going to do is we are going to, as I said already, we're going to look across both specifications, biology A and biology B specifications. We're going to look at some of the mathematical requirements that are required within the specification. And hopefully by the end of the session, we'll have achieved a couple of aims. Hopefully we'll have improved your knowledge of the key mathematical concepts that is required of the specification. We'll look at some ideas for teaching approaches towards the end that will help you to deliver some of these mathematical skills. Our main focus for today is going to be looking at some specimen questions. So we're going to be taking some questions from the 2024 examination series, and we're going to be focusing really on the most difficult questions that the most challenging questions that faced the students in the 2024 series, and then looking at the mark schemes, and obviously then along with that, looking at addressing any common issues and then any questions that you may have at the end. Just because it's drawn my attention, you can see it right in the corner of my screen, there is the chat box available to you as mentioned at the start. Please feel free to have discussion in the chat box or ask any questions. It is quite difficult for me to obviously do the presentation and pick up chat questions, but at times I will pause and have a look if there's anything sort of that's impertinent, that catches my eye and picks it up. But really, obviously you have the chat box there, and at the end, if there's anything particular that's come up a number of times, I'll go back to the chat box and address those issues. What we're going to do today is the main sort of agenda, and the main topics that we're going to look at today is the ones that were identified as most challenging, the mathematical concepts that were identified as most challenging across the 2024 series. We're going to look at ratios, we're going to look at converting units, calculating rate, the command word determine, which always challenges people, and I'll be doing a little bit of a section looking at command words, and then statistics that are required, the statistical calculations that are required in the specification. So just to start us off, to get a bit of a feel for what sort of people we have in the room, what sort of teachers we have in the room. First, going to do a couple of polls for the first couple of slides. The first poll is just a bit of an idea of how long you've been teaching A-level biology. So I'm going to launch the poll. You'll be able to see there are a couple of options: new to teaching it, 1 to 3 years, 4+ years, or you're not currently teaching it at the moment. Take about another 10 seconds. If anybody else wants to, we're nearly there. Okay, perfect. I'm going to finish off and I'll share the results. So we've got a selection of individuals today. The vast majority of people in today are 4 years plus into teaching the A-level biology specification. We've got about a fifth of the group in who are 1 to 3 years, and we've got about 10% in who are new to teaching it. So we've got a good spread there, and please feel free, anybody who has been teaching it for, for a period of time, 1, 2, 3, 4, 5 years, maybe even longer than that. Some people are teaching it 10 plus years. Please feel free when we come to looking at some of the specific topics that we're going to cover, on ratios, converting units, etc. If there's anything in particular that that you want to mention, or anything that you've noticed that actually helps or supports students, or any techniques that you have in your classroom, please feel free to add them into the chat and share those with other individuals here today, other teachers that are here today. That would be fantastic. The second poll that I have is just to sort of get an idea of what specifications, although we're going to cover both specifications today, but just to get a bit of an idea, a bit of interaction at the start, just to see what specifications you're teaching. So either specification A, specification B, or obviously, if you're not teaching at the minute, not applicable. So if you can have a respond to that. Okay, no, stop it there. So the largest percentage of people here today, 63%, are those who are specification A, and we've got just over a third of people here who are delivering specification B. So we've got a mixture of across the two specifications. And as I say to you, the questions that have been picked out today to look at in particular, the most challenging sort of mathematical questions, skills questions, are again from both specifications. And I've actually, in the presentation, I'll highlight to you what specification each question's from and what paper they relate to as well. Last one, just to finish off for the moment. How do you feel confident in teaching level 2 maths? So obviously the requirements for this specification is that it incorporates level 2 mathematical skills. How confident do you feel, or do you feel confident teaching these? So is it just a yes or a no, or somewhat? Do you feel confident? Yes. No, you don't feel confident, or you feel somewhat confident? Okay, perfect. And I'll share the results with you. So 50% felt that they were confident teaching level 2 maths in terms of specification. We had about 7% who don't feel confident at the moment. Hopefully we'll change that by the end of the session. And then with 43% that feel somewhat confident. Maybe just need sort of a couple of strategies or a couple of ideas to look at maybe some of the more difficult concepts within the specification. Okay, thank you so much for participating in those three polls to get us started. It's giving me a bit of a feel for the audience that I have in front of me. I have a few more polls as I go across, or as I go through the presentation, and I do appreciate your participation in those. I know what it's like at the end of a day. I'm sure some of you have been teaching all day, as have I, and it's tough at the end of the day to log in and to be going to a development course. But I really do appreciate your enthusiasm for joining in today. I do appreciate that. Okay, so just a bit of a sort of a background to where the maths relates to biology. In the A-level biology specification, 10% of the total marks must come from level 2 maths, and obviously there will be some more advanced topics beyond that, looking at logarithms and looking at statistics, but in general, there's 10% of the total marks must allocate to level 2 maths. There is a slight differentiation across the two specifications, A and B, and you can see there where there's sort of a slight differentiation, but in the vast majority of situations, they are vastly the same. They're mostly the same. And as I've said to you already, what we're going to look at today is we're going to focus on, across the two specifications, which questions the students found most challenging. One of those areas that we're going to start off with today is the area, or the section on ratios. That was one of the particular sections that students found most challenging. I know also that This can be a challenge in mathematics as well. I was delivering a GCSE mathematics, GCSE, sorry, science, mathematics and science course last Thursday as well. And I know I was sort of have been collaborating with some of the maths team over the last couple of weeks. And I know this is one of the topics they mentioned as well that students find difficulty with in maths as well, GCSE maths, is ratios. So just going to have a look at a question. This was probably the most challenging question across the 2024 specification, despite the fact that it was quite a straightforward question. It was just they had to have that particular mathematical skill of understanding ratios. So as you can see there, this is from specification B. It was from paper 1. It was question 7B part 2. They were given some data looking at a different species of bird, coal tits, blue tits, and great tits. They were then given some information on the length from head to tail of each species of bird, their wingspan, and their mass. And what you can see there is that's quite a stark statistic. The success rate of this question was 7.6%. That really does signify the fact that ratios are quite a challenging skill and concept for the students to understand. And maybe they might even not, they might even have that skill in maths, but what we can see here is it's applying it to a different context. So one really important thing is that your students must be able to, as well as having the skill, so being taught the skill, they must be able to actually transcribe that skill or put that skill into action in relation to a context. I was saying in my session that I was giving last week to the GCSE scientists, what I was saying was that in my school, what we have developed is we've developed a strategy bank and a video bank. The strategy bank is for our staff members. This was created by our numeracy team and maths department. And the strategy bank literally goes through a number of mathematical skills, ratios, percentages, fractions, etc. And what they have done is they've created videos for teachers in the science department on how to teach the skill. What they're showing us is when I watch them, if I'm teaching a skill of ratios or fractions, I can go to this strategy bank, I can look up the strategy video on ratios, and I can see how they're teaching that skill in the maths classes. There's also then a video bank for students, and the students then have access on an online platform to a video bank of just a reminder of how to do ratios, how to do percentages, and then the maths teacher and the numeracy team going through some examples. So yes, we also do need to teach the students and remind them on how to what the skill is of ratios, but then applying it to the setting. So let's have a look at this particular question. It says calculate the length from head to tail. Calculate the length from head to tail mass ratio for the great tit. So what we're looking to do here is we're looking to compare the length from head to tail to the mass for the actual for the great tit. What you can see, I'm going to put you on I'm going to show you on the next page the mark scheme for this question. And the mark scheme for this question shows that it's literally a 1 mark answer, and all we're looking for is the fact that it should have been 0.8 to 1. Now, if I just go back one slide to answer this question, we're focusing on the great tit. So we're looking at only the data for the great tit. We're looking at the head to tail length for them, and we're looking at the mass. So it's 14 to 18. The important thing to remember here is that the second number or one of them must always be to 1 in terms of a to 1 ratio. So if that's why we have this 0.8 to 1 ratio, okay, that's what the answer should have been. So if you're taking the 14 to 8, which was the original, and what we do then is obviously dividing the 18 by 18 to get the 1, and then obviously doing the same to the other side, taking the 14 and dividing it by the 18 as well. So that's where we would have come down to the 0.8 to 1 ratio. Why can anybody into the chat box if you feel you want to? Does anybody have any ideas or anybody have any suggestions? I don't have an answer to this question. It's just if we have any sort of suggestions. Why should this simple ratio prove so difficult to students? Why? I'm going to look at an answer that a student is given in a moment or two, just so we can see their processing. Anybody have any ideas or they want to share with us? Why should this simple or why is this simple ratio so difficult for students? I've sort of one suggestion. Yeah, absolutely. Incorrect rounding, absolutely, totally agree with that. Thank you, David. The incorrect rounding of it, absolutely, because the question does specifically state, just, if I just remind myself, it does specifically state in the question, and that's important. It's emboldened that it's to one decimal place, so that's important. They haven't rounded it properly, and they haven't read that emboldened text correctly. Also, somebody has said there about students overlooking the data. Absolutely. Sometimes, they don't know where to focus on the data, and they get quite confused about what they're actually looking at. So they are. Um, Somebody else said someone's going to. Yes, somebody made a good point there that in GCSE maths, students are expected to give a ratio to a simplified whole number as well. So yeah, absolutely, I do agree with that. The one thing that I think here is the fact that it's a context, the fact that they are having to apply that skill to a context. I think that is um particularly, a wrong answer. That's where they lose out on marks. They know the skill, but when they're having applied to a different context, and somebody said there about looking at using different units, different data, that sort of throws the students. Let me show you an example of a student here. So here the student has obviously got the initial 14 to 18. But what is important to understand is that in this particular scenario, what the student did was they went for the first number, and they calculated the ratio based upon the first number being to 1 rather than the second value being to 1. So what is important to remember here is that whenever the students are asked to calculate a ratio, the skill to learn is that the second number should have a value of 1. So it should, and that's where we get the correct answer, obviously, in this circumstance, and where the students are confused. So the student actually knew what they were doing in this scenario, however, just didn't address, it correctly, and actually did give it to the correct number of decimal places, but you can see the misconception there. For this student, it should have been 0.8 to 1, so it should have been. Another example here of ratios. So this was the fifth most difficult question. This was from specification A, paper 2. The success rate, a little bit better with this one. The success rate was 33.2% for this particular question. It was question 10A. Again, it's an application to a context, to a scenario. So you can see there, I'm not going to read through all the details of the question, but they had to do a couple of things in this question. They had to do more than just work out the ratio. So what they were actually asked for in the question is they were asked which of the following shows the ratio in its simplest form of female to male athletes in this investigation. So actually, first of all, there is no female athletes attributed, in the table. You can't actually see the figures for those. It gives us the total number of athletes, and it gives us the number of male athletes. So what they had to do first of all here was they had to work out how many female athletes there were, and obviously deducting the male from the total. So that in the first scenario for endurance, that gave us obviously 27 take away 12, left us with 15. And then the mixed training, that was our 31 take away 22, left us with 9. So we had a total of 24 female athletes to a total of, and obviously you had to add the 12 and the 22 to get the total male athletes. So add the 12 and 22 give us 34. So it was of a ratio of 24 to 34. And then what they obviously had to do was then bring that down to obviously its simplest form in the ratio, which ended up being 0.7 to 1. So again, they had to know that it was bringing it down to the second number being 1. And actually, if they knew that, that was the important thing about this, that would automatically be able for them to knock out B and D. So they knew it was either going to be A and C. They just had to work out which one it was by doing the correct calculation. So they had to take the 34, obviously divided by 34 to get the 1, and then the 24 females, they had to divide that by 34, which came up as 0.7. So really the takeaway here is for students, it's about knowing that they must convert the second number to being 1. And there again is that's just what I was talking about there. There is the explanation where the answer is 0.7 to 1. And what they had to do was obviously subtract the males from the total to get the females, and then create the ratio of females to males. All right. Again, anybody want to sort of put anything in here, please feel free. If there's any sort of why you felt, I can see straight away why I felt this would be a tricky question for students. It is only a 1 marker. Anybody want to share anything? Yeah, absolutely. Misuse of data, confusion between different sports. Yeah, definitely. That's what I feel. When you look at the data, if I just go back to it's students obviously trying to work out and be confused by the data. And actually, again, somebody made a really good point there about across both sports categories as well. Or which sport? Yeah, absolutely. So about knowing which sports to do it across, whether it be the endurance or the mixed training. So there's a misconception there as well. But I suppose the fact that they're referring to the number of athletes suggests that they should be looking at the number of athletes across both sports, for females and males as such. But yes, it's the application to the data. It's the set of data which is confusing. It's not the background information beforehand. It's actually the getting to grips with the set of data. So one thing that I would suggest, as an idea, and I'm sure most of you already do this, is obviously past paper questions. Past paper questions are probably one of the most important aspects of developing a skill like ratio. Exposing your students to a wide range of different data sets that allows them to be able to calculate different ratios from different tables of results, allowing them to be able to manipulate that data and obviously see how data can be presented in many different forms, to allow them obviously to develop that skill. Not necessarily the skill of the ratio, that's maybe quite an easy skill to get, but it's actually the skill of then, as we said already, applying that to a context, and being aware of the context as such, and being able to succeed in that context. One more example of ratios, which we have here. In this particular example, again, it's a different data set. This is why I'm stressing to you the importance of looking at a range of different data sets. So in this particular question, we're looking at a graph. This was from specification B. It was paper 3, slightly higher success rate, and that might be due to the fact that the data is simplified, a little bit more simplified. So it is. So there was a success rate of 41.7% in this particular question. And in this question, it was looking at the concentration of urine varying between species of mammals: kangaroo, rat, camel, human. And what they were asked in this question was to determine the ratio of urine concentration across the 3 mammals. So kangaroo, rat to camel to human, obviously with the last digit being been down to 1. So they obviously had to read off the graph, and you can see the students done that in this particular question. So for the kangaroo rat, 5,500. For the camel, just seeing there because my screen's up, I think it was 2,800. And then for the human, sorry, my chat box is blocking this. I'll go back. For the human, it was, is that 1,400, I think. Yeah, 1,400. So with that in mind, then obviously, as you can see, the student here has done that correctly. They've obviously done 5,500 to 2,800 to 1,400 as their ratio. And then what they've done is they've taken the last number, which is 1,400, and they've divided everything by 1,400. So they brought it down to 1 for the last number, 2 for the middle number, and then 3.9 then for the first number. So they've got a 3.9 to 2 to 1 ratio. So once you've learned that skill, they've got that skill now, which you can clearly see this student has. It's just about the application to whatever data set's put in front of you. But I do think there was a better success rate in this particular question because the data set was probably easier to read. So it was than maybe some of the previous data sets that we've looked at. So exposing the students to a range of different data sets, and obviously looking at a range of different past paper questions like the ones that I've just shown you will definitely help with building that ability to deal with questions like that. Okay, so moving on to our second section, we're going to look at converting units. Again, one of the challenges, and this sort of comes right through from GCSE, where students often find it difficult to convert units, and it's something that's difficult to teach, because again, yes, it's a skill, but where do students get this skill from? Certainly, I believe through my experience and um, teaching science and biology, I definitely think that conversion of units does lend itself to completing practical activities. I think by completing practical activities, in particular, core practical activities, and allowing students to actually gather raw data and then use that raw data and give some questions in relation to conversion of units, etc. I definitely think that does help with the situation. One thing that I have found is quite helpful is having learning mats on my tables, and part of the learning mat is there's a section on converting of units. It just means that it's on the desks within my classroom. It's constantly there. They're constantly referring to it, and I think if they have the ability to constantly be seeing these conversion units or conversion tables and be constantly being drawing back to them, whether it be through practical activities, through past paper questions, through learning the core content, it sort of keeps it in the forefront of the mind, and it also keeps bringing back to it practice, 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 in order to get this concept across of converting units. Here's an example of a question from specification B. This is in paper 3, success rate about 30.1%. And this question was asking, so it gave them a procedure for looking at differences in water potential. And the question then asked them, it told them in the first part of the question that a stock solution of 0.8 mole per decimeter cubed was obviously created, and that was then used to make to dilute to make a range of different concentrations. And what they were asked to do here was to describe how you would prepare 10 centimeters cubed of a solution of sucrose that had a concentration of 0.6 centimeters, sorry, 0.6 moles per decimeters cubed from the original stock solution. So again, we're integrating ratios here. So the first thing that they had to do was they had to work out obviously the correct ratio for the conversion of the for the for making up the correct concentration, and that was obviously 3 to 1. So they got a mark on this question for 3 to 1. And then the second thing was that they had to have a correct volumes to make up the 10 centimeters cubed based upon the 3 to 1 ratio. So 7.5 centimeters, you can see in the acceptable guidance column there that it could have been 7.5, to 2.5 water. However, there was also an acceptance if they had, said 7.5 and make it up to 10. They didn't have to explicitly mention the fact that they had added the 2.5 centimeters cubed, so they didn't. And you can see in this particular student's response that they gained 1 mark in this particular response. 1 mark only. Anybody want to stick into the chat around where they think the 1 mark was applied to in that particular student's response? Yeah, I do agree. I do agree with Stephen there as well, and thank you, Stephen, as well for the 6 to 2. It is quite a difficult question for 2 marks, and even beyond the mark, and it was applied. It is quite a difficult question to work out the ratio in the first place. But yes, you're right, Stephen. Thank you for also replying there. The 6 to 2 ratio is where the student got the mark for in this particular question. Where they didn't get the ratio, where they didn't get the mark was the fact that they didn't have the correct amounts to make it up to 10 centimeters cubed. They mentioned about 0%, or maybe that even maybe 6%. The writing's quite difficult, but maybe it's 0% of sucrose and 2% or 2 centimeters cubed, sorry, of water. So they haven't actually got the correct volume. So that's where they lost the mark. So they got it for the 6 to 2 ratio, obviously, which simplifies to 3 and 1. So 1 mark applied, and you can see if I just show you in the next slide. Sorry, what mark would you give? I've already discussed that. Oops. Sorry, I've lost where I was going. Sorry, I was going to this slide. Yes. So what I was saying was 1 mark, I say, because the candidate got the ratio correct, but the volumes were too low to make up the required 10 centimeters cubed as such. So just gives you an idea there of a particular question in relation to that. Now, this sort of links back to what I was saying at the start of this section on converting units. Now, not necessarily this particular one, but I have something very similar. This is what I would use in my classroom. It definitely has benefited. Something like this that is on the desk that allows students to see very easily and very quickly how a conversion takes place and how you do a conversion. And obviously the prefixes as well as that for the conversion. So obviously if this is on a student's desk, this could be on the learning mat as part of I actually use it with a few other things on a learning mat. I have sort of some keywords in relation to command words that commonly appear, or common misconception command words, so like determine and things like that. And I also have a section on graphs as well. So some sort of keywords in relation to trends and graphs and things. So part of a learning mat, this being on the desk, students are constantly reminded of what is important, and obviously the conversion of units, bringing back to it as well. And as I've said to you, and I've mentioned this already, past paper questions is really good for practicing this skill, and obviously practicals as well, completing practicals and manipulating raw data to do as well. But yes, I understand and I appreciate converting units in some occasions can be very easy. In other occasions, it can be very difficult and very complex to look at, and it can be very complex for students to do, depending on the question and the scenario as well. Again, sort of links back to that first example we're looking at of ratios. Again, it is affected by the context. The context does make it again slightly more difficult. There's a lot of information for students to maybe understand, and it's a very simple or straightforward question, or maybe only a very small amount of marks. But applying the context and knowing the context is also important as well. Okay, so we're going to look at our third sort of skill set today, looking at calculating rate, looking at logarithms. Going to look at a few questions here in relation to this. The first question that you can see on this slide was a question from specification B, paper 1. This one had the third lowest success rate overall, and it was 23% success rate for this particular question. I do think, when you first look at a question like this, it's very dynamic. There's a lot of information being this. It's not a straightforward set of data. There's a lot going on in this particular set of data. You can see first of all that obviously you've got your time after fertilization in months at the bottom. You've got your percentage of globin subunits synthesized on the y-axis. You can see up the top you've got some information about structures responsible for synthesizing the globin units, subunits, and then obviously then you can see the different subunits there, gamma, beta, epsilon, delta within the graph as well. So there's a lot of complex piece of information to look at. In this particular question, there's a couple of things for students to focus on. We're looking for a calculation of the rate of decrease in percentage of gamma. So really, the first thing that's highlighted here is we're only focusing on the gamma globin subunit. Okay, we're focusing on a time period of between 7.6 and 10 months. So again, the student must be able to look at this particular graph, and they must be able to understand the reading of the x-axis and the scale of the x-axis for the time after fertilization in months. And then the next thing that they must do is they must not ignore that last bit. They must not ignore the fact that the answer is, they're specifically saying here that the answer must be given to two decimal places with appropriate units. So that's where the 2 marks is coming into play here. So they must not ignore, and that's why it's in bold, so that the students particularly pay attention to that. However, that is one of the things that students in particular miss the most. What is the actual finishing of, they do the calculation correct, but what is the actual end point here? Is it 2 decimal places? How many significant figures is it, etc., etc.? And that's where they tend to lose marks in a section like this. Have a look at the mark scheme for this particular question. In this particular question, I think I've got a poll set up. There is a response at the bottom, and the mark scheme is at the top. Let me just see if I can get this poll going. Just give me one wee second. Yeah. Okay, go with this one. So what mark would you give for the response that the student has had? So it's obviously out of 2 marks. Would you give 0 marks, 1 mark, or 2 marks? I'll give it 30 seconds for this. Okay, gonna finish and share the results. So vast majority of people, 59%, nearly 60% are saying 1 mark. Nobody said no marks. That's definitely correct. And we had about 41% saying 2 marks. In fact, for this particular question, for this response, the student was allocated 1 mark. The reason they were allocated 1 mark is because correct. Thank you, Stephen. They actually didn't give any units as such. So if I go back to the question in total, it does say specifically give your answer to 2 decimal places with appropriate units. So what the candidate has done here, the candidate has actually read off the graph correctly. They have read off the graph just to remind myself. So they've read off the graph the percentage of globin subunits at 7.6 months. They've also read it off at 10 months. They have subtracted the difference between those two and divided it by the time period, the difference of between 10 months and 7.6 months, which was 2.4 months. And then they've got 21.67, which is the correct answer. However, they should have had in there a unit, and that should have been something like percentage decrease of globin per month, something along those lines. So they should have included their units in there. So what happened here was the student was able to calculate the rate effectively, but they didn't read the question fully. They missed out. And I said to you before, that's quite often what happens with students. They just miss out on reading whether it's how many decimal places it is or whether it's units or not. And that's where they miss out on marks here. So 1 mark allocated to this particular student in that case. Okay, having a look at the next question. Just bear with me 1 second. Yep. So having a look at the next part, just going to give you sort of before I go into the next question, a common rate calculation is to look at the rate at a particular point. I was actually doing this with my class today, and looking at by drawing on a tangent to a curve as such. And students, quite often, find that difficult to calculate a rate at a particular of a curve as such. So it's about practicing, that graph and that skill of being able to draw the tangent, and then obviously being able to look at calculating the rise over run, basically, the y-axis and over the x-axis, and then looking at the applicable units for that. So looking at the units of the y-axis, looking at the units of the x-axis, and then being able to then create, if necessary, if it asks in the question, the applicable units for that. So you can see here just an example of how that's done, obviously, and obviously that's just through practice, lots of practice with students of doing that and calculating the gradient and talking about the terminology. That's a really important point as well. Looking at the terminology that's talked about, tangent and gradient and rate, and how we calculate that for the particular question. So it is. So you can see there, yep, just an example of that. Have a look at this particular question. This is a question, second most difficult overall for the 2024 series. This was from specification A. Hopefully you can see we're looking at sort of a bit of a split between the two specifications. Again, also you can see we've tried to cover some of the different papers, paper 1 and 3 have been included, some paper 2 questions there, but this one only had a success rate of 18.3%. This was a particularly challenging question. Again, it's the data set again. It's looking at the data set and saying that, students are faced with this data. If they can't interpret data, if they haven't been faced with challenging questions like this before, through past paper questions, then they're going to find a question like this challenging. Obviously, yes, they have to know the skill of being able to do this, but ultimately when they look at this, there's a lot of information. You can see here we've got bacteria species P at the top, we've got bacteria species Q, and then obviously you've got a key at the side, which is looking at no antibiotic, antibiotic A, antibiotic B, etc. Fluoxetine, you can see there as well. And then you've got the question at the bottom. So they have to look at the data, they have to interpret the data, what's on the x-axis, what's on the y-axis, what are all these lines showing us? And then the question asks, calculate the mean rate of decrease in the number of cells in the first 4 hours of species P for antibiotic B. So the question is telling specifically there, this is a 2-mark question. The question is telling specifically what graph they're looking at. The question is telling specifically what what line they're looking at here in terms of focusing on the data, what part of the data set. They don't need all of this data set, and therefore the students need to read that correctly to be able to understand what they're looking for here. So, in this particular question, I'll do another sort of poll quickly. This is a 2-mark question. Again, we've got the mark scheme here. That is, you can see the 2 marks. So there has to be obviously the correct conversion from the log number to the actual number of cells at the start. So they have to know how to do the anti-log. And then second of all, they have to then from that be able to calculate the rate by dividing it by 4. And that comes obviously from the graph. So it does that to be able to calculate the rate knowing by dividing by 4 to get the final answer. I just double checking, did it say in any sort of decimal places, etc.? No, didn't actually specify to how many decimal places as such. So just going to launch the poll, have a look at the student response. Just give me 10 seconds to do that. So going to launch and just see what marks. Okay, going to stop there and share the results. Thank you so much for participating in that. So this was allocated as 1 mark. That's correct. The vast majority of people got that right. 79% of people agreed with 1 mark. There was a couple of people that went for the 2 marks, and then a couple of people went for the 1 mark or for the 0 mark. Sorry, as well. So it should have been 1 mark. And in this particular scenario, the student actually got the 1 mark actually for the error carried forward in the first in the first bit, or sorry, in the second bit. So they did. You can see there down there it says allow 1 mark for the 6.8 divided by 4, and that's what the student got it for the 1.7. So they got that as the 1 mark. In this particular scenario, the difficulty was, and I think this was identified in the examiner's report. A lot of students didn't know how to use their calculators correctly. And from again, if I just go back to the event that I did with the GCSE Maths team last week, one of the Chris Segar, one of the points that he was making quite heavily was that when they're teaching maths, as soon as they arrive into his school, one of the things that they ensure is that they have all got the same calculator. They recommend a particular brand of calculator, and he said that certainly goes no ends to helping to actually teach the the skill of using the calculator. If they all have the same calculator, it makes it much more easy. Students really, when they're coming into almost GCSE and A level, more so in into A level biology, should be aware of how to use their calculator and how to use different functions. As you said there, Stephen, as well, students don't know how to use their calculators correctly. In terms of the shift log 6.8, that's a skill. That's what that needs to be very clearly taught in how to actually, how to actually do anti-log, and how to for a question like this, how to use their calculator to do that. So spending a little bit of time in looking at some of the functions of the calculator, particularly when it comes to questions like this, particularly when we look at some of the statistics questions later on as well, it's definitely a key thing to do. Spend some time looking at what type of calculator a student has, and then, and as Chris said, sort of, sorry to keep going back to the GCSE event we did, but as Chris, correctly said, not everybody's going to come in with that calculator that you recommend. He said that there's quite a number of, he didn't realize how many different brands of calculator there was, and that actually it ended up there's maybe 14 or 15 different types of calculator in a room. But particularly at A-level biology, students should be getting familiar with how they actually use their calculator and the different functions that can help them to answer some of these questions. Okay, going to look at one more question in this particular section. I'm going to do one more poll in this question. So again, down to calculating rate. So this was taken from specification A. This was a slightly higher success rate, 37.2%. Taken from paper 2, and it's all about resting heart rate in individuals. The candidates were given the fact that an adult male had a resting heart rate cycle of 90 beats per minute. And it said that the systole stage was found to be 30% of the cardiac cycle. Calculate the length of time for a single systole stage for this person. So in this particular scenario, I don't actually, I'm just trying to check here. There might not be on the slide. No, there's not. I was going to do a poll there, but there's no mark scheme. But actually, what you can see here is in this particular question, was allocated 2 marks, and the student was correct in their answer of 0.45. They were allocated the full 2 marks because what they did was they took the 90 beats per minute. They found 30% of the 90 beats per minute. So they took the 90, they divided it by 100, and they multiplied by 30. And then what they did was then they divided that by the 60 seconds to make it to find out that it was 0.45 seconds. So they found out that correctly. They could have done it. There was different ways of doing that, but there was you could have done it the other way by taking 30 divided by 100, and then obviously before dividing that by 60 as well. So there's different options there. But yes, sorry, Stephen, there, I can pick up your point again. Thanks for contributing again. Appreciate that. The wording of the question was not very clear. So yeah, sometimes maybe what the information that's provided there can sort of divert students away from the question. But yes, I can see in this particular question, there's a couple of pieces of data in what they're doing, but just to show you there's an example of a student that performed it correctly and how they completed it in stages. I'm going to come back to this towards the end of the presentation, but just to highlight this as well, just because this student has completed this, it is really important that students are actually showing the stages in their calculation. Now, this is only a 2-mark question. This will be sort of more of applicable when it comes to maybe the stat questions at the end. But in a question like this, or a stat question, it is important that students are showing the stages in their calculation. What that allows for is that allows for the examiner to see the thought process of how the student was answering this question, and it may be able that they are able to allocate some marks or even error carried forward if it applies to looking at a couple of different, it's linking a couple of different questions up in a full set question. So laying out and showing they're working out is very, very important. Obviously, if they don't do that and they have the correct answer on the line, well, then obviously they still get the marks. But it is still important for students to get into that matter of habit of showing the stage by stage, scenario of how they got to that end point. It definitely helps. So it does. Okay. Going to move on to the 4th section today. I think after this, we've got one more section on stats to look at. We're going to look at determine, one of the command words that's used in the Pearson Edexcel specification. And, about 3 weeks ago, I was doing a session looking at AO3, how to address AO3 questions. And one of the things that I said was the importance of understanding the command words, the importance of being aware of what the command words mean. If you look at either the specification A or the specification B, you will very quickly find at the very back in the appendix a list of the command words that are used, and also definitions or explanations of what those command words mean. That's a really invaluable resource for students to be able to have a list of all the command words. That list will not be necessarily exhaustive, but it will include the vast majority of command words that are available to the students, or that are maybe going to be expressed to the students in the examination, with a very small few exceptions. And if they are able to understand those command words, that's really important. But the key thing here is applying those command words. So looking at past paper questions and seeing how to address those command words in different contexts. Really, really important. One thing that I do quite often to look at command words in the classroom is to do a little bit of a peer assessment. And what I do is I sort of I teach in an all girls school, so I would give out the girls a range of different command word questions with different command words, and I get them to answer the question, and then I get them to swap with their peers to mark the question with the mark scheme. And then what we do then is we get the peers and the students to provide some feedback to each other on where they didn't address the command word correctly, if they didn't address it correctly. So some feedback on that, and it really helps both students, or sometimes I do it in groups, it helps both students understand where the significance is of these command words in answering the questions, and what actually the examiner is looking for in answering these questions. So what we're looking at here is, in this particular, I'm going to show you a question in a moment or two. It says that this was the sixth least successful question in paper 3 of specification A, with a success rate of 33.4%. It was a ratio question, so it sort of links back to what we talked about at the very start of the session. And the command word was determine. I'm going to show you a response to and a question to this particular ratio question determined that was asked. And this response gained no marks because there were no values that were used. And that's the important thing that I'll mention in a moment or two about determine. So have a look at the question. You can see here we've got a data set, and in this data set, what it was looking for was to determine the mean ratio of carbon dioxide produced to oxygen consumed. So it was looking for, and it was, sorry, at 17 degrees. So in this particular question, it was looking for, again, a ratio. Well, first of all, we look and we see that actually the ratio was incorrect because it was not 2:1 as such. And what we can see here is that in this particular question, it was using the word determine, all right? And by using the word determine, what that is suggesting is that when if you look at the command word list at the back of the specification, whenever students see determine, what they should automatically think of is the fact that it should include data, some sort of data. I'll show you another question here on the next slide. I'll show you another set of questions which alludes to this. So here is sort of a couple of snapshots of some questions where we have the word determine. So you can see here you've got the first question at the very top about BMI. It includes the word determine. You can see there's another question down at in the left hand corner, where it is temperature against lifespan. Again, mentions the word determine. The top one is more explicit. You can see the top one, it's giving you an equation. So it's a lot more explicit to students that it's actually requiring data, that there's some sort of quantitative element in the answer. So obviously, a student's getting that calculation at the top there, or that question at the top, and they know straight away it's a calculation. Data is required, and therefore there's going to be some sort of quantitative answer to that question. However, if you look at the second question down in the left-hand corner, it's the temperature and the lifespan. That question asks to determine the relationship between the increase in temperature and the change in lifespan. So a student may look at that question and ultimately think that all they're asking for in that question is a trend. The trend between temperature, or the relationship between temperature and lifespan. The fact that as temperature increases, lifespan decreases, an inverse relationship. However, in that particular question, it's a 2-mark question. That will get them 1 mark if they're identifying that inverse relationship, if they're identifying that trend. The second mark, because the word determine, the command word determine has been used, it's really important that the students are given some sort of data from the table to back that up. So, if they could talk about, comparison between 15 degrees and 30 degrees and how it drops from 130.3 to 20.4, some sort of, or a difference between them. They have to get to the point where they realize that the word determine means there must be some sort of quantitative element to this particular response. And again, can only stress to you that comes through either providing the students with a list of command words and what they mean, practicing them by exposing students to a range of different questions with the word determine and seeing where it applies, and even showing them questions like this whereby it isn't always explicit, and maybe even, like I mentioned before, that I would use in my classroom, bringing in the peer assessment where they're marking questions up with different command words, and being able to provide feedback based upon the mark scheme for that as well. Lots of different techniques for that particular strategy. On to the final section. The final section to look at is looking at statistics. Probably one of the most difficult aspects for a lot of students, particularly if they don't bode well with math skills and concepts, being able to understand um, complex statistical calculations, or being able to extrapolate data from graphs or from table sets to input into statistical calculations. It can be very difficult for students if they don't have that strong mathematical grasp as such. So a lot of these calculations come in stages. It's stepped, it's staged. Um, it requires a number of different, procedures to be calculated to get to the final answer. And this is where I was mentioning about how students should write down all of the steps and stages that they're performing, because that they can be allocated marks even if they haven't got the answer correct at the end. One thing that they can do wrong is in this process is by rounding up after each stage. And if they do that, they're going to end up potentially with the wrong answer, the incorrect final answer. An important thing to get across to students when teaching statistics and multi-step calculations is to explain that no rounding should take place until the final point. And quite often, in bold, like we've seen before, it will clearly state to the students how many significant figures or how many decimal places the student should have in order to gain the final marks for a question like this. So it's really important that they read the question carefully. It's really important that they look at the data set. And it's really important they look at anything that's emboldened within the question in relation to how the final answer should be given. That's a really important tip to look at. What I quite often do is when if I have some sort of presentations on screen for students that I may be going through some questions, I always try and include little exam tips at the bottom when I'm covering some of these skills. So if I'm looking at a ratio, looking at the aspect of ratio, and I'm doing some ratio questions, exam tip, make sure that the last number is 2-1. If I'm looking at statistics, exam tip, do not round throughout the stages. Make sure you look at how the final answer should be presented. Make sure you address your calculation in stages. Just a couple of exam tips that's pointed out to them quite specifically about how to answer particular questions like this and addressing concepts like this. Going to look at another question here in a moment or two. I'll bring it up on the screen for you. It's question 8 from the specification B, paper 3. Quite a good success rate, 51.1%. It involved calculating the correlation coefficient. I've just pointed out what I've said there now. You can see the last point there, two things that I've already mentioned actually that students did wrong. They didn't, in this particular question, common error was they give the answer to the wrong number of significant figures. and therefore they didn't take instruction on the bold point that was put into the question. And that's why it is in bold, and that's why it's bold, to draw the students' attention to it. But I think quite often the students get zoned into the equation, they get zoned into, what the different symbols mean. They're also going to have a data set in relation to this as well that they're looking at. So they do get zoned out, they do get zoned in on particular things, and it all comes down to that exam stress, etc. Where they're focusing on they're focusing on the things that aren't important, and then they just write the answer down, and they haven't actually written it down in the way that it's required to be presented: three significant figures or decimal places, etc. So you can see in this particular question, they've shown what each of the different symbols are. There would have been a data set that was obviously applied to this question as well, maybe before, at the top of the question as such. And what you can see here is that the student has then obviously used the different parts of the calculation and worked out an answer at the end. I'm going to show you in the next screen the mark scheme for this. So you can see here that the first mark is for working the sum of d squared, 236. The second mark is the intermediate step, which you can see is looking at the sample size and working at the bottom half of that calculation, which comes up as 1.967. And then the third part is coming relating to the emboldened part, which is that it should be the three significant figures. The candidate, if I just go back, the candidate who answered the previous question, they got the first part right, as you can see there. They got they've done it in the second part down. They've worked out the sum of d squared. They've got 236. But what actually they've done wrong here is they have actually incorrectly identified n, because there are 9 sets of values. And if we go back again, sorry, n refers to the sample size. So they should have been counting up the number of different samples that were actually being looked here. So 9 was the number of samples. Yes, actually, sorry, Alexander's just put in there. I'm not, to be honest, I'm not sure to comment on that question, but yes, I do see where you're coming from. Possibly error carried forward for marking point 3 if they've performed, the actual calculation correctly and they've given it to 3 decimal places. That is a potential. However, I honestly can't comment because I'm not sure on the marking of that particular question. But yes, I do take on board your point that if the student had correctly calculated the sum of d squared, hadn't done the intermediary step correctly, but had then followed through with the correct answer, or sorry, with an incorrect answer, but done the steps correctly and got the correct number of significant figures, potentially it could have been so it could have been and I can see there actually that, if you look at the third step down, just in relation to your point, Alexander, they've taken n as 88.9, which we know is incorrect, but actually they've actually done that correctly. You can see 88.9 in the bracket squared minus 1, and then multiplied that by 88.9, divided it by the 6 times 236. So potentially yes, but I just don't want to comment on that because I'm not quite sure of the specifics of that question. So they achieved marking point 1, but they didn't achieve the other marking points in this particular scenario. So they didn't. Okay, so that is what I've looked at is over the course of the last hour and a bit, which has actually flowed in there. I've looked at the misconceptions that were addressed in the 2024 series, being ratios, being converting units, looking at rate and logarithms, looking at determine, and looking at statistics. I just want to sort of bring that all together for you, just to sort of finalize here the last few bits. And to be honest, I'll probably finish up a little bit early here, which is sure good news for some of you. I probably will only be about 5 or 10 minutes just to finish up this last section, sort of concluding and bringing it all together. So, an important statistic to look at is that the mean success of the maths questions in 2024 was 50% for specification B and 53% for specification A. So that was sort of the mean success rate. As I was going through each question, I was sort of giving you some ideas of what each question was in terms of their success rate. And therefore, what I'm showing you now is I'm showing you that The overall success rate, taking all of those into consideration, was 50% for the maths questions in specification B and 53% for specification A. In both cases, it was slightly better than the non-maths questions. However, as I'm sure you're aware, and as I'm sure you agree, there is still room for plenty of room for improvement there. The maths skills are GCSE standard, as we addressed at the start of this presentation, level 2, grade A star to C. So there definitely is some room for improvement. I'm not sure maybe of what students, the sort of caliber of students that you have into your A-level biology courses, whether there's a stipulation of what grade they need to have at GCSE. But yeah, officially they should know, or they should have they should have that standard of A star to C in terms of their mathematical skills for moving forward into the A-level biology. Some sort of tip, and I've mentioned a lot of these sort of tips as I've went through. So learn and practice unit conversions, including the 1,000 rule for converting units. So that goes back to the fact of the learning mats that I was talking about. Maybe there's another way you want to do it. Maybe you work off booklets for the students, etc. Having a particular page or a laminated page that the students can always refer to on those unit conversions. In terms of calculations and formula, etc., writing out each step, really important so they don't lose marks, and really important that they don't round up as such until the very end point. And then also looking at the formula. Quite often some of these formulas are provided for them, and it's about knowing how to input the data into that particular formula, like we just seen in that last question on the correlation coefficient. Make sure, really important, this came across from the examiner's report and across different multiple papers and across the two specifications. Make sure that students pay attention to any instructions that are in bold. Typically, they will give students instructions on how to put the final answer in terms of significant figures or in terms of decimal places, etc. So always paying attention, and that should be something they should be checking through at the end if they have time left over, checking through that they have addressed any sort of bold sections that are key within the calculation. Read the question and look for keywords like rate and determine. So knowing the command words, knowing the keywords that are in the question, making sure that they are picking out those bold, those particular words that are standing out that help the student to answer the question specifically, letting them know what is important for them to understand in the question to get the correct answer. That determine keyword I mentioned about, if you went to your appendix. Appendix 7, I just looked at, had noted down there. Appendix 7 of both specifications relates to the command words. And if you look at Appendix 7, you'll see a list of command words there that are specific to the specification, and about knowing the definitions and the explanations of those command words, really, really important as well. Knowing how to use the calculator correctly, so knowing how to use the different functions of the calculator, knowing specifically how to use antilog, and working out questions in relation to that, and knowing their calculator. There's no point them having a calculator in class every single day for a year, whatever, or 9 months, and then on the day of the exam having a different calculator or having to borrow a calculator. That really will put a student off. It's really important that they have calculators, and they are really important on how to use those calculators, specific calculators that they have for them. The other thing I wanted to say on calculators, there was a mention at the GCSE event about, Chris had said from the maths team that, if possible, I know it all comes down to finances, particularly for maybe A-level or GCSE classes, about buying a class set of them so that students had access to a specific calculator and everybody was sort of as such reading from the same hymn sheet and being able to perform the same functions. Just makes it easier for the teacher as well to be able to perform these functions and show how it's done on one calculator rather than actually showing how it's done on multiple calculators. And I suppose then that calculator could be used on the day of the exam. So that's just another suggestion from the maths team as well. Learn how to use the stats capabilities of your calculators to calculate standard deviation. So learn how to interpret standard deviation. One thing that I always start off with my students in doing standard deviation, just to get them to understand it, is I quite often incorporate the use of standard Excel spreadsheets looking at standard deviation. So I always start off obviously by looking at the equation, and then we sort of do a bit of practice with it by collecting, looking at a range of different data sets, and we use an Excel spreadsheet that has some of the rules set in for calculating standard deviation, and we practice that way obviously first of all, and then we look at a lot of we look at a lot of different calculations as such. A lot of different examples, sorry, of what I'm trying to say, in terms of passive questions. So remember, there are only 3 stat tests. Learn their details, including the null hypothesis. So we're talking about chi-squared. We're talking about the t-test and the correlation coefficient, or the Spearman correlation, sorry, as well in there. So 3 stat tests that are mentioned in the specification, including null hypothesis and the 4-step conclusions. So if you what I would say in terms of the stat tests, what is really important is the practicing of those questions. The students being able to actually input the data, just like we looked at in the previous example there of the student answering the question of the correlation coefficient. Yes, the actual calculation, the equation was given to the students, but them knowing what the different where to get the different letters, the different aspects from, to be able to input into there, you could see very clearly that student didn't know, they didn't know where, what n referred to, what, the number of samples, etc., and how to get that, and that meant they lost out in the question. So just lots of practice with those particular questions is really, really important. I've also mentioned about the video clips. I know that's a massive undertaking for a school and a department to do, but I definitely recommend, engaging with something like that, some sort of strategy bank and some sort of video clips for students. Even maybe if you didn't have the time to do it with your in collaboration with the maths department, even if it was, quite often I find we use online platforms. We use Microsoft Teams for our prep for our school, and quite often what I would do is I would create, on an app, sort of worked examples, scaffolding, going through sort of me taking a question, deconstructing the question, and sort of step by step going through how to do, whether it be a stat question, whether it be a determined question, whether it be a rate question. And then what happens is I then upload that into my online platform, Microsoft Teams, and the students then have access to that to constantly go back to it, to sort of recap on it, to build upon it, and they can see the step-by-step processes. If they can take that step-by-step scaffolding and then apply that to different scenarios, that's the key that we want our students to learn. Applying that to different scenarios is really, really important. So it is. As always, you have availability to contact the subject advisor. The details for the subject advisor are on the Pearson website. Please also remember, sorry, something else I should have mentioned just when I mentioned the Pearson website there is a wealth of resources on the Pearson website. I mentioned about Appendix 7 being the command words. If you also go on to the specification and you look at Appendix number 6, Appendix number 6 is looks at mathematical skills and exemplifications. And what it does is it goes through a lot of the skills that are required, mathematical skills that are required in the A-level biology specifications. That might help for you to, when you're mapping out your schemes of work and your teaching, across the terms, to look at the mathematical skills and what's required. So Appendix 6 Appendix 6 of each specification highlights the mathematical skills that are required. So that's Appendix 6 and that's Appendix number 7. I would definitely draw your attention to looking at those. Okay. As well, we always have a range of different professional development courses which you can find in the Professional Development Academy, and you can also see other courses that are available on there. One thing that I would suggest is at the end of this you will receive a questionnaire on feedback. I'd really appreciate that if you could complete that, because we do really appreciate your feedback and take on board the feedback that you provide. One thing that I would say, and I always say at the end of my courses, is for everybody to think about the short term and the long term takeaways from a course. we always go on courses, professional development courses to try and improve our teaching, to try and improve our skill set. One thing that I would say to you is, when I always go on a some sort of CPT course, the first thing I do is I always look at, and I always think to myself, what can I take away and what can I implement within my classroom here within the next week or the next 10 days? Something I can do really quickly that has benefited me from this course, that is going to actually have a direct benefit on my students, because that's the reason why you're here today. The reason you've decided to come to this course today is to see how can you benefit your students, how can you improve student success. It could be that you've taken away that idea of the learning mat, that you're going to create some sort of conversion table or some sort of learning mat, something very quick and snappy that you can set on a student's desk or you can put into their folder. It might be the videos that I mentioned there at the very end, about where you can go away and you can create some um staged or constructed or sort of scaffolded videos of exemplar questions that you can allow students to view from home and whenever they want, whenever they're doing their revision. And then last of all, what I would say is, what are your long-term takeaways? There's things that you can take away hopefully from this session that are not going to be done today or tomorrow or in the next week. What are the long-term takeaways? What are you gonna work on over the next sort of 2 or 3 months, maybe for the next academic year, that you can put in place for your students for next year, and what can you help them in terms of improving student success? So just, I'm not asking you to sort of to generate those for me now, but I'm just asking, that's sort of what I would be reflecting upon in terms of, as teachers, we're always reflecting. We're reflecting at the end of a lesson, we're reflecting on at the end of a year. I always like to have self-reflection at the end of a CPD. What can I take away? Short-term, long-term goals. Folks, it's 20 past, just coming up on 20 past 5. I really appreciate your time this afternoon. I really hope that I have given you some sort of idea of the mathematical skills and concepts across the biology specification. I think it was very important that we addressed it in relation to the 2024 series from the last series, and I hope that that will allow you now. We've got a little bit of time before the start of the summer series. As I said to you, those short-term goals, those are things we can put in place now that will hopefully slightly improve student success coming into the 2025 summer series. I wish you all the best with your upcoming examinations with your students, and hope you have a lovely evening. It's great weather here. Hopefully, you've just as nice the weather as where I am. And thank you so much for attending today, and have a lovely evening.